Ironclad. The first time I met Sebastian Hoffmann, I was leading a structural assessment team documenting the catastrophic failure patterns of the Ambassador Bridge. He emerged from the Canadian side carrying real-time steel fracture analysis. He moved with professional desperation. His expression made it immediately clear that what we were looking at wasn't just a failing bridge, it was a humanitarian crisis. We had maybe 72 hours before someone died under 7 tons of compromised infrastructure. My name is DeShawn. I'm 36. I'm a structural engineer for the Michigan Department of Transportation. My job is to assess the safety of bridges that were built decades ago. Those materials are now failing in real time. I've been doing this for 13 years. I've condemned bridges, I've coordinated emergency repairs. I've made decisions that kept hundreds of thousands of people safe. What I hadn't done was meet a German bridge engineer, someone who could look at American infrastructure failure and instantly calculate 17 different intervention points that nobody else had considered. Sebastian was tall, maybe 38. He had the kind of physical precision that comes from German technical education. His blonde hair showed professional graying at the temples. His blue eyes processed structural data like other people process conversation. His accent belonged in Berlin, but he'd somehow ended up in Detroit, coordinating emergency infrastructure, moving with intensity that suggested he'd been born specifically for this crisis. I was standing on the bridge deck at 6:30 in the morning. I was running my hand along a section of steel. It had started showing stress fractures 6 months ago. Now it was showing something worse, active degradation. The metal was warm to the touch. Despite the Michigan morning cold, that wasn't normal. That meant internal stress was exceeding what the material could handle. "That's worse than your official report indicates," a voice said behind me. The accent was German, clipped, absolutely professional. I turned. Tall guy in a consulting jacket with insignia I didn't immediately recognize. Blonde hair, blue eyes, expression that suggested he'd been reviewing structural data while most people were sleeping. "And you are?" I asked. "Dr. Sebastian Hoffmann, Transport Canada, Structural Engineering Division." He extended his hand. "I've been analyzing the Canadian approach data. What I'm finding doesn't match what the American assessment team is reporting, and I need to understand why there's a discrepancy." I shook his hand. His grip was firm, confident, the grip of someone who knew exactly what they were about to tell me would change everything. "Show me," I said. We went to my office at MDOT headquarters. Sebastian pulled up his tablet and showed me data that made my stomach drop. Real-time fracture mapping, steel composition analysis, stress load calculations that factored in traffic patterns I hadn't fully accounted for because the datasets from the Canadian side hadn't been shared with my team. "This is showing the bridge is degrading 400% faster than anyone calculated," I said slowly, looking at the numbers, "because the traffic loads are 400% higher than when the bridge was constructed in 1929, Sebastian said, not unkindly, "and because the American assessment team and Canadian assessment team have not been communicating effectively. You're measuring one thing, we're measuring another. Neither of you have the complete picture." "How long do we have?" I asked, though I was already calculating it in my head. "Best case scenario, 72 hours before we see structural failure that could be catastrophic." He met my eyes. "Worst case, much sooner. The fracture pattern I'm seeing suggests the stress could cascade." I thought about the 40,000 people who cross this bridge every day, 10,000 of them commercial vehicles, families, commuters, trade flowing between Michigan and Ontario. "You came here to tell me something else," I said. "It wasn't a question. I came here to tell you that I have a solution," Sebastian said, "and I need someone who can make it work in America. Someone who understands both the infrastructure and the bureaucracy. Someone who can move fast." "How fast?" 72 hours fast. Maybe less. I looked at this German engineer who'd emerged from the Canadian side with data I didn't have and a solution I couldn't imagine. "Tell me," I said. "Osfafton I sofa stun. Arotha sofa from meteor spopto wires thymol and the bobbermorki seti remains beloskius. Daptitude century sing some bells. Adenditude from the wisif stun. And brose to quati handu to dofi vlo to tachi fell fast and septims. At a soy soft time and to cantip, but the seed still time. Adenda win you to make it 2 time to the nays. At a soy softum to toy warki scores langry witikiv. I've seen the lutold. I'm resoys. I've seen the late suggesting curd the studilite wait. Aleo I save a late when on. We worked through that day and into the night. Sebastian and I pulled up architectural records from the 1920s, comparing them to current structural data, identifying points of failure that the individual assessment teams had missed because they weren't communicating. The Ambassador Bridge wasn't just aging, It was degrading faster than anyone had calculated because the stress loads had increased exponentially since construction, and the steel composition, while revolutionary for 1929, wasn't compatible with modern traffic patterns and weather cycling. By 2 o'clock in the afternoon, I'd called in additional team members. By 6 o'clock in the evening, we had a conference call with Transport Canada. By 9 o'clock at night, we had federal contacts briefed. By 3 o'clock in the morning the next day, Sebastian and I were still working, and I realized I hadn't left the office. "You should sleep," Sebastian said at one point, looking at me across the conference table where we'd spread out blueprints and structural diagrams. "So should you," I replied. "I've been awake for 38 hours, he said. "I'm German. We're trained to function without sleep during engineering crises. It's part of our education system." He said it without irony. "But you're American. You'll need rest." "I'll rest when we know if this is possible," I said. "Tell me the full plan, everything." He did. It was elegant and terrifying, and absolutely brilliant. Not a complete bridge closure. That would devastate commerce. Not a repair timeline of months. We didn't have months. A controlled emergency retrofit using modular reinforcement techniques that could be installed within 72 hours, working 24-hour shifts, coordinating across the international border with precision that was mathematically audacious. The modular system would attach to existing structural elements without compromising them. The installation sequence had been calculated to ensure that at no point would any section be without adequate load-bearing capacity. The integration with existing infrastructure had been designed with such precision that traffic flow could be maintained throughout, at reduced capacity, but maintained. "This has never been done before," I said slowly, reading through his calculations. "No," Sebastian agreed, "it hasn't. Which is why it's terrifying, which is also why it's the only thing that will work. The politics of this will be worse than the engineering," I said. "Then you'll have to be very good at both," Sebastian said. "I can design the intervention, I can coordinate the structural implementation, I can ensure that every component meets specifications, but I need someone who understands American bureaucracy, who can navigate state and federal regulations, who can make both the Michigan side and the Canadian side trust that this is the right move." It was simple and elegant, and completely terrifying. "The retrofit starts at 6 o'clock tomorrow morning," Sebastian said. "We have 72 hours. Do you want to sleep or do you want to keep working?" I looked at the blueprint spread across the table. I looked at this German engineer who'd arrived with impossible data and an impossible solution. I looked at the clock showing 3:47 in the morning. "Keep working," I said. "What else do we need?" We kept working. By 6 o'clock in the morning, exactly when the retrofit was supposed to begin, Sebastian had specifications sent to steel fabrication plants in both Michigan and Ontario. By 8 o'clock in the morning, I had emergency permits filed with both MDOT and Transport Canada. By 10 o'clock in the morning, I was briefing state officials in Lansing. By noon, we had federal authorization. By 2 o'clock in the afternoon, equipment was arriving at the bridge, and the retrofit was beginning. For the next 72 hours, Sebastian and I coordinated the impossible. He was on site constantly, moving through the bridge structure, assessing each reinforcement installation, making real-time adjustments, ensuring that every modification enhanced structural integrity without compromising the existing framework. He was in constant radio contact with the fabrication teams, with the installation crews, with the structural specialists who were working on both the American side and the Canadian side. I was coordinating with officials, managing traffic flow, communicating with bridge operators, ensuring that the work was happening according to timeline. I was in the MDOT operations center, but I was also at the bridge when I could be, understanding what Sebastian needed before he had to ask for it. We were in constant contact, phone calls at 2 in the morning, radio checks every 30 minutes, text messages with updated specifications. A partnership that developed a kind of shorthand. Sebastian would call, "Section 4A is showing lateral stress." I would respond, "I can have additional bracing equipment there in 90 minutes. Will that work?" He'd adjust his timeline. I'd coordinate with officials. We were thinking as a single system with two expertises. By hour 36, the critical sections were reinforced. The main load-bearing elements had been supplemented with the modular system. The bridge was still fully functional, traffic was still flowing at reduced capacity, and structurally we were seeing improvement in real time. By hour 60, the secondary reinforcements were installed. By hour 68, we were testing final components. By hour 70, the structural integrity tests were showing that we'd not just stabilized the bridge, we'd actually improved it beyond current specifications. By hour 71, at approximately 5 o'clock in the evening on day 3, we were running final systems checks. At hour 72, exactly on timeline, the Ambassador Bridge was reopened to full traffic. I received the final structural integrity report showing that every measurement was within acceptable parameters. Better than acceptable, they were excellent. The bridge was safe. Not just safe, it was stronger than it had been before. 40,000 people could cross it tomorrow without risk. Trade was flowing across the international border. Sebastian and I stood on the bridge at 6 o'clock in the evening on day 3, watching traffic flow safely across the international border, and I felt something shift in my chest that had nothing to do with professional satisfaction. "We did it," Sebastian said quietly. He sounded shocked, which was remarkable because this was a German engineer who'd calculated every variable. "You did it," I corrected. "I just coordinated logistics and bureaucracy." "No," he said, turning to face me fully, and there was something in his voice that made me pay attention. "We did this together. Your knowledge of American infrastructure standards guided my structural design. My engineering made your coordination possible. Without you, I have brilliant designs and no ability to implement them across the border. Without me, you have bureaucratic authority and no technical solution." He paused, and in the golden hour light with the bridge structure all around us, I could see exhaustion and something else. Clarity, maybe. Recognition. We're a complete system, Marcus. Together. The bridge was saved. 40,000 people were safe. Trade was flowing. Commerce between Michigan and Ontario wasn't disrupted. And Marcus DeShawn, standing on an international bridge that shouldn't have survived another 3 months, looking at a German engineer who made it possible, realized he'd just fallen in love with someone who made him capable of more than he thought possible. "I need to ask you something," Sebastian said, and his voice had changed. It lost the professional tone and became something personal, something vulnerable. "Okay," I said. "Are you seeing anyone?" I laughed, exhausted and adrenaline-soaked and absolutely clear on my answer. The laugh came out a little shaky. "No, are you?" We dated for 6 months while the Ambassador Bridge continued operating safely. The retrofit became a case study in emergency structural intervention. Universities around the world studied what we'd done. The first date was at a German restaurant in Detroit. Authentic, precise, the kind of place where everything was exactly as it should be. Sebastian told me about growing up in Berlin, about learning engineering in a system that prioritized precision above all else, about his family. His father was an engineer, his mother was a mathematician. His entire childhood was filled with conversations about structures and systems, about how things worked. "I came to America because I wanted to see infrastructure built differently," he said over schnitzel. "American bridges are built with pragmatism. German bridges are built with precision. I thought maybe I could learn something from American pragmatism." "And have you?" I asked. "I've learned that pragmatism and precision aren't opposites," he said. "You're pragmatic about what's possible. I'm precise about how to make it work. Together we're stronger." We dated through the summer and into fall. He extended his consulting contract, then extended it again. Then he got a permanent job offer from the Michigan Department of Transportation. When he accepted it, he looked at me. "I'm staying," he said. "For the work, yes. The infrastructure challenges here are genuinely fascinating. But also for you, for us." The bridge retrofit became famous in engineering circles. We were invited to conferences. Universities wanted us to speak. We published a joint paper on emergency cross-border infrastructure coordination. It won an engineering award. But what mattered more than the professional recognition was what happened between us. Dating became commitment. Commitment became discussions about future. Future became a conversation that started with Sebastian pulling out a small velvet box. We were standing on the Ambassador Bridge, exactly where we'd stood 72 hours after saving it. It was early December, cold but not yet snowing. The Detroit skyline was visible on one side. The Windsor skyline was visible on the other. "Are you seeing anyone?" he said. I laughed because it was our joke now. Our origin story repeated. Our connection acknowledged. "No. Are you?" I already knew what was about to happen. "I'm hoping to change that," Sebastian said. "I've been thinking about structures, about what lasts, about what survives pressure and stress, about what continues serving its purpose, about partnerships that get stronger because of the challenges they survive together." He pulled out the ring. "I want to build that with you, Marcus. I want to marry you." The ring was white gold. It had small bridge girder designs etched along the band. Minimalist. Beautiful. Perfectly German engineering translated to jewelry, with a distinctly American sensibility. The bridge itself was incorporated into the design. "Yes," I said. "Obviously, yes." Epilogue. 1 year later. We got married in a small ceremony in Detroit. Both families were there. My family from Michigan. Sebastian's from Berlin. From his childhood scattered between Germany and the United States. We wrote vows. They reference bridge structures and cross-border connectivity, precision and partnership, the specific language of engineering translated into the language of love. You taught me that engineering serves people, I said in my vows. My voice was steady despite the emotion. You taught me that the strongest structures are built through collaboration, not competition. You taught me that international cooperation isn't theoretical, it's practical, necessary. It changes everything. You taught me that precision and pragmatism aren't opposites, and you taught me that the best partnership is one where we're both stronger, because we're building something together that neither of us could build alone. You taught me that bureaucracy and precision can coexist, Sebastian said in his vows. His German accent was more pronounced with emotion. You taught me that American pragmatism and German engineering aren't opposites, they're complementary. You taught me that sometimes the most important thing an engineer can do is bridge differences, literally and figuratively. You taught me that the person who sees your weakness and doesn't judge you, who works with you to overcome it, that's the person you should marry. And you taught me that home isn't a place, it's a person who understands your specifications, your precision, your need to build things that last. 1 year after the bridge retrofit, we'd moved into a house in Detroit. We had a view of the river. We could see the Ambassador Bridge from our bedroom window. Sebastian was consulting on emergency infrastructure projects across North America. I was leading the Michigan Department of Transportation's Structural Assessment Initiative. We were collaborating professionally on a project to assess and retrofit aging bridges across the Great Lakes region. We were collaborating personally on a life that made sense to both of us. 2 engineers building something that would last, that would survive pressure, that would be stronger because of what it had survived. One afternoon we were sitting on our porch, overlooking the river and the bridge in the distance. Sebastian said, "Do you ever regret that bridge crisis?" "Never," I said. "That bridge crisis brought you to my office at the worst possible moment. Somehow that was exactly the right moment, because you were ready to solve an impossible problem," Sebastian said. "Because you arrived with the solution I didn't know I needed," I corrected. "Professional and personal, you made me capable of things I didn't know were possible." He reached over. He took my hand. "German and American," he said, "both building something that works, something that lasts, something that's stronger because of the pressure it survived," I agreed, and he kissed me. There overlooking the Ambassador Bridge, the structure we'd saved together, the structure that had brought us together, the structure that had taught us what partnership actually meant. I thought about all the ways a structural crisis had brought 2 engineers together, how precision and partnership had created not just a bridge that saved a city's commerce, but a love that would sustain both of us for decades to come. Sometimes the best structures are the ones we build together. Sometimes they're the ones we never stop building, redesigning, perfecting, because we understand that partnership, real partnership, is a system that requires constant attention. It requires willingness to adapt. It requires precision. It requires pragmatism. It requires 2 people who understand that strength comes not from rigidity, but from flexibility, from collaboration, from trust. Sometimes the most important bridge we engineer is the one between ourselves and another person, the bridge that spans the gap between different backgrounds, different countries, different ways of thinking, and creates something that neither could create alone. And sometimes you meet them at the exact moment you need them most, when the stakes are highest, when the pressure is most intense, when the weight of everything depends on collaboration. You realize this is who I'm supposed to build with, not just for the crisis, for everything that comes after, for the life we're going to engineer together.